So columns 1 and 2 were two of the first ones I would uh, of the first two that I'd like to do, and so let's just talk about these for a second, and then figure out how we're going to do it, and then let's divide it up and see who can do which ones. Okay, so anyway, the poles and zeros are not nearly important to me as the did Luke, do you have one of these sheets? Okay. Well, I'm giving you my last one here that I've got. So you guys are going to have to help me with this is called in the parking lot. Got a call from a guy who wants to Sandusky High School wants to do the Rubik's cube. So I spent my 10 minutes with him instead of printing out any more of those. So I'll so Kuzno's not here, right? He's not come back. Okay. There's nothing wrong. So you're going to have to help me today. So what is the Laplace transform of that first one? And let's just, okay, so 9A, 9B, 9C, 9.1A, 9.1B, 9.1C, and then max 9.2A, and then, forgot your name. Nathan. Can you do 9.2B, and Kang, can you do 9.2C? Can you see that? All right, so let's just give you a second, and then we get the answers, because I don't have my sheet anymore, because I'm not, whatever. Didn't have time this morning to get enough, but I think I've got it memorized, but anyway. So how do you do the Laplace transform of this? Okay, huh? So it's, what is it? It's 9.1A is minus 8 over S, right? Okay, it's easy. B, what's that one, Leo? 0.5 T. I don't have my sheet. Where, is that right? Does everybody agree with that? Okay. Ethan, C. I'll give you 10 something. S plus 20,000. Yeah. Everybody got that? So this goes, these aren't so bad. They get worse, okay? Max 9.2A. Now this one does not show up on your screen. Let's just use, instead of the d of delta, let's just use the delta. Minus 10 delta. What is that one? Minus 10. Minus 10 delta is that. I think minus 10 d delta is minus 10s, I think. Okay. Minus 10, okay, so do you see that a constant is minus 10 over s? That'd be a constant, okay? That's just u to the t, right? That's this one right here. Okay, so that's like a step function. What's the derivative of a step function? The delta function, okay? What's the derivative of the delta function? The double delta function, whatever that is. I have no clue. What's the derivative of that? I do not know. I don't think anybody knows. But theoretically, it would be minus 10s. Because every time you take the derivative of something, you take it times s. So the derivative of this is this, the derivative of this is, put an s in front of it. Okay? The derivative means s in general. Okay? Take the derivative, and it's the s of it. If it's an integral, what is it? It's 1 over s. Okay? That it. Any questions about A? I think that's what he means, and I really don't care about the double delta or the delta of the delta, but it's minus 10 is just the delta. Did you find that on the sheet? It's down there someplace. It's way down in the middle of the sheet, but it's there. Which one? Number 6. You got, I don't have one. I sacrificed giving a sheet today because of the call. Okay, everybody agree with that? Does everybody see that? The delta function is just the number itself. Okay? The derivative of the delta would be minus 10s. Anyway, it's beside the point. 9.2b.
Would it be s or 120s over s squared plus 377 squared?
Yeah. Yeah. S squared, it's s squared plus 377 squared. Yeah, that's it. That's right. What you said? Yeah, good. Like I said, without a sheet in front of me, I'm kind of flopping around. But anyway, C, Kang.
I don't have a sheet of paper.
You don't have one either?
Sheet of paper.
Yeah, you don't have one of those either? Well, anyway, what would be 1 minus e to the minus t? The constant 10 would be 10 over s, right? Minus 10, what, over s plus 500. Isn't that right? Everybody agree with that so far? Now we're moving along. We're going to forget about this poles and zeros. Although poles and zeros are important, that's a minor point as far as I'm concerned. Okay. Find the Laplace transform of this. So this is going the other way. This is going, what this was doing was going from the time domain to the, oh, this is the same thing. This is more of the same thing. So let's just keep going. Number 6. Luke, number 6. 1 minus cosine of 500t. Okay, what is the 1? 1 over s? Okay, minus Is that right? That's it? Okay. All right, that's it. Does anybody have any questions about that one? Number 7, back to you over here. We're back to starting 7. We're gonna do some of these. We're not gonna do them all. We're gonna do 7, we're gonna do 9. We're not gonna worry about, we're gonna not worry about 8, but 7, we're gonna worry about. What is this one? It's 20 times 5 or 100. Okay, times what? Cosine 100, cosine of 100t. Okay, minus 100. What? Sine. What is sine? Any questions about that one? Okay, number 9. I'm going to skip number 8. We're going to number 9. Leo? Yep. The delta function is just 1. Okay, minus 3 times what? Yep, very good. That's all that is. All right, number 10. We're going to go on. Moving along, number 10. And what do you think? Laplace transform of the following. Okay, so what would be the following? What would be the transforms of these? A 9, 10A. Very good. B. Max? 10 times what? What is cosine of 1000t? Somebody help him? Huh? Yeah, it's 10 times cosine of 1000t minus cosine of 2000t. Can you see it okay?
Yeah.
Say again?
S over S squared plus positive.
Plus what? What's this one? 2000t. Any questions? That's all it is. Simple. Piece of cake. Okay, now number 11. We're gonna skip around. We're not gonna do them all. We're gonna do some of them. 9.10, 9.11a. Okay, 9.11a would be Nathan.
To start, you put the delta, you just get rid of it, right?
Yeah, it just goes away. It's just 2. Yeah, it's just 2. Yeah.
Plus, and then when you have two things like that are kind of times together like that, how do you do that?
You look on your sheet. Yeah, This is why we're doing it this way, because, yeah, there's a lot of questions, and it really is, it's a, whatever. It's just, this is, I looked at this and I said, Ted, you could go through these and you could do them all yourself, but I'm just gonna do them as a group. And then this morning I was gonna run the sheet off for everybody, and I got that call. I didn't want to be too late, didn't want you to leave, so I didn't run off the sheet, so I'm running blind. But I want you to work these problems, and we're not gonna do them all, but 11 is one of them we're gonna do, okay? So,
Would it be one? Or no, it'd be 144?
yeah, times something.
Or wait,
It's
No,
144 is just a constant, so it just goes on for the ride. But what's the t e to the minus 12t? What is that one? Sounds right.
or s plus 12, and then that whole parenthesis is square.
Yeah, that sounds about right. That's about it. Yeah. Does everybody see that? Is that right? Because I don't have the sheet in front of me. I'm flying blind. Okay. If you don't have one of those sheets, I'll bring one on Wednesday, but you can get them from the website for my EET 4450 class. Okay, so you can download it off of that if you want to keep a copy from between now and then. But basically, that's where I have them stored. This is the same stuff that we do in that course, but in this course we go further. So it's actually this course does, in some cases it does actually more than that course. So anyway, B, 11B.
Uh, still spread over S.
Yes. Plus 50 something. What's 50? No, this is e to the minus 10t cosine plus sine. What's e to the minus something cosine something? What is that? Is that on a sheet? Ethan, is that on the sheet?
It's E times sine and 8 cosines. Two, two. Could be. Um,
Okay, so is there one that does the combination of e to the minus 10t cosine of 100t?
plus 10 squared plus 100 squared.
Okay, let me just look at the sheet for a second. So let's look and see what I got, because I want to get it. I want to have a copy of it so I can. So under courses, EET 4450, examples, it's under that. It's under that. Okay, so under that is. Okay, so examples, save. Okay, so download. It's going to take forever for this thing to load. So here's my table. Right here is my table. And I got to make it bigger. Yeah, it's 19. It's 20. This is my rule right here. It's rule 20. Okay, so that's the rule you want. Okay, so it's rule 20, which is S. Okay, so rule 20, which is e to the AT cosine of BT is equal to S plus U minus A over S minus A quantity squared plus B squared. Okay, so that's your rule. Let's go back and look at the question. Okay, so here is E, it's 50, then it's e to the minus 10t. So what is e to the minus 10t? So what is A is equal to? A is equal to minus 10, right? Write it down. Okay, A is equal to minus 10. Does everybody see that? By that rule. E to the AT, e to the minus 10t is A is minus 10. So write the A is minus 10. And then you also write down B, which is what? 100. Okay? Now your translation of that is equal to what? E to the minus 10t cosine 100t is what? S minus, or S plus 10 over S plus 10 quantity squared plus 100 squared. Is this, just this part right here. Now, what is e to the minus 10t sine 100t? That is rule 19, which is the B term. Okay, so this is rule 20, this is rule 19, which is e to the AT sine of BT is equal to B over S plus, S minus A quantity squared plus B squared. That's a mess. It's messy. Let's go down back and clean it up. All right, we'll get it cleaned up. Or S minus A quantity squared plus B squared. So what is, in this case, A is still minus 10, B is 100. So basically it's the same thing. So it's S plus 10 over plus 100 over S plus 10 quantity squared plus 100 quantity squared, and that's your final answer. So that's the translation of that one. Okay? Any questions about that? That's 11B. We're going to skip these. We're going to go down to 18. So I'm skipping some of this stuff because it isn't really important, but anyway, well, he goes way off the deep end in some cases, but we're going to get the basics. All right. Number 18. Now this is the other way. This is going the other way. This is going from the frequency domain back to the time domain. Okay? So, where are we at? Luke, 918A. Okay, it's 1,000 what? E to the minus 2,000 T. What do you notice about this course different from the other course if you've taken 4450? They use big numbers here, right? They don't just go with 4 and 5 and 10 and 2 and that. They use 2,000 and all that kind of stuff. Why is that? because we're going to be dealing with frequencies that are in the thousands of hertz, kilohertz, that type of thing. We're going to be dealing with numbers that we're going to get numbers that look like this as opposed to just 2, 3, 5, 10, 20, that type of thing. But the same principles hold in both cases. So you can, you know, you can grunt and say, I don't like this or whatever, but it's the same thing. It's the exact same thing. Okay, that's A. B. We're back to Zach. Okay, now what, this one, S over S plus 5 times S plus, what is this one? Where's that on your sheet? Anybody find it? Now, some sheets do have this kind of on it. So they do go a little bit. This one, I don't see it on there. Does anybody see it on their sheet? Anybody see this on here? No. So what must you do? You must go with separation of variables to get it to something that you can put on this sheet. So separation of variables is the only way to do this. So it's equal to what? You gotta do that. Okay? It's an unknown. Now you gotta find the unknowns. It's a pretty easy one, but you gotta do it. This is the only way you can do it. Any questions? So once you go off the sheet, off the rails, you have to go with separation of variables, the generally accepted practice. So now how do you do this now? I'll write it out. I'll write it out like this. I'm going to get rid of all denominators. So I'm going to just do the numerators is equal to A times S plus 10 plus B times S plus 5. Does everybody understand that what I did was get rid of all the denominators? I got the denominator over here is equal to the denominator over here because I cross multiplied these. I cross multiplied this and cross multiplied that, put it on a common denominator, cancel the denominators out, and now I'm down to this. S is equal to A times S plus 10 plus B times S plus 5. How do you find A and B in this case? Let S equal what? Minus 10 is one of them. What's the other one? Minus 5. Okay, if you play that game, what's going to happen? A is going to fall out, B is going to fall out. All right, so if S is minus 10, what is it? Minus 10 is equal to A times S plus 10, which is what? 0, plus B times minus 10 plus 5, or what? Minus 5. Everybody agree with that? A term goes away. B term's equal to what? 10 over 5. 2. Everybody follow that? If you let S equal minus 5, what happens? Well, minus 5 is equal to what? S is equal to minus 5. A times S minus 5 plus 10 is what? 5 plus B times minus 5 plus 5, or 0. Or this goes away. So A is equal to what? Minus 5 over 5, or 1. Now I've got it. A is equal to 1. B is equal to 2. Now I can write it. I can write my final answer. What's my final answer? I go back to my sheet. and I find what it looks like for that. So it's equal to what rule? Right there it is. Rule 2. So my final answer is 1e to the minus 5t plus 2e to the minus 10t. I'm done. Your little whatever, and you're done. Okay, that's it. Piece of cake? No. You have to recognize when you go off the sheet. Let you do that. Always look at the sheet first. Always look at the sheet first. But once you find that it's not on the sheet, you can't find it and you've never seen it there before, then you go off the sheet, and this is how you do it. It's pretty straightforward. Separation of variables, all right? Now there's more rules to separation of variables than this one, but this is the simplest one. The general rule of separation of variables is the numerator has to be 1 power of s less than the denominator. If s to the 1 up here, you can't have an s term up here. If you had an s squared term down here, what would the numerator be? as plus b. If you had an s cubed term up here, it would be as squared plus bs plus c. So the rule basically says for this kind of an operation, you have to have the numerator 1 level less than the denominator. In this case, straight old a. Okay. That's that one. That's the rules. Okay, so now let's go to C. Leo. Okay, C. 918 C. Okay, so it's, yeah, you cannot, this is not on the sheet, so how would you do it? Okay, I'm going to say S times S plus 20, and I'm not going to even put the denominator down as equal to what? I'll put the denominator down because it's important. S plus 10 times S plus 30 times S plus 50. Okay, is equal to what? Very good. Now, when you rewrite it, S times S plus 20 is equal to A times S plus 30 times S plus 50 plus B times S plus 10 times S plus 50 plus C times S plus 10 times S plus 30. Let S equal what?
Negative 30. No, negative 10 for A.
You plug them into this formula and away you go. Okay, now I'll give you all a chance to do this. I'll do it and see what you come up with. Okay, so what is A? This is messy. This one is not as easy as the other ones, but you all find, somebody find A. A equals, B equals, C equals, and I'll write them in. I'll let you do it, okay? You find A, B, and C with this one. I want to see how you do. Okay? S times S plus 20 is equal to A times S plus 30 times S plus 50 plus B times S plus 10 times S plus 50 plus C times S plus 10 plus S times S plus 30. Let A, S equal to minus 30, minus 10, and minus 50. Find A, B, and C. I want you to do that. I want you to have to do this kind of stuff because you will have to do this on a test. This is not an option. You will have to do this. When you get an answer, just put your pen down and I'll ask somebody, but try to try to get the answers up to this, okay? It's calculator time, that's all it is. This is plug and chug, that's all this is, but I want you to be able to get this. This is good practice. Max, you got them? When you get them, let me know. Somebody give me the number. Leo, you got them?
Yeah, I got
What's A?
that
One what?
-8,
-8?
1/8.
1/8, okay. B. C. 16/8? 50/8?
15.
15? 15/8?
Right.
So what's your final answer? Excuse me, it's minus e to the minus 10t/8 plus e to the minus, excuse me, minus e to the minus 30t over minus times 3/4, and then plus 15/8 e to the minus 50t. Is that about it? Everybody agree with that? Good. That's it. These are not hard, but they take time, and I want you to understand you got to go through that process of getting all those numbers, the A, the B, the C, or you ain't going to get there. But you need to be able to do that. Okay, that's 18C. Now I'm just going to have you do 19A only. B and C get really messy, but A is not too bad. Okay, so this one is the same thing. It's just, I tell you what, I'm going to skip 19A because you can work this one at your leisure if you want to for practice, but I'm not going to work it today. We're going to keep on going. Okay. So we're going to go down to 23. All right, so now you have a different set of criteria. This is a little bit different. What is this one? This is and Leo, it's up to you, 19. This is 923A. So, what's the story here? What are you going to do here? Is there anything on the sheet that looks like this? No, I'll give you a clue, there's not. Then you have to ask the question, is this factorable? All right, so it's going to be 100 s over s plus 1 quantity times s squared plus 21s plus 20. It's going to be a over s plus 1. That's a given, right? The next question is this one right here. Is that factorable? Can you factor this? The answer is yes. It's what? What are the factors of this? Yeah. So is this any different than the other ones? No. So what is the split? You're done. You see that? That's all it is. How do you know if it's factorable? Good question. This is high school algebra all over again. It really is, because you got to figure out if it's factorable, all right? But if it is, you're in. Some will be, some won't be. Okay? So that's 23A. Now 23B, and again, you find the A's and the B's. Nathan, what?
How do you handle the denominator being the same for A and B? Is there like a special trick, or do you just like do it?
Good question. Okay, so how do you handle that? Good question. Let's solve this one all the way through, because that's a good question. I didn't notice that until right now. Okay. How would you handle that? Well, you can get rid of one of them. You can get rid of the A or the B, but you can't get rid of both of them. That's a good observation. Okay. So what you got to do, and this is not hard, but it just takes time. Okay, so here we go. Let's erase part of this stuff. Okay. Okay, so here is the split. It's 100 s equal to A times s plus 1 times s plus 20 plus B times s plus 1 times s plus 20 plus C times s plus 1 quantity squared, right? Now, you can get rid of really none of these. Because if you let, well, you can if you let s equal 20. If you let s equal 20, you can find C, right? S equal minus 20. You can get rid of A, you can find C, all right? So that's how you find C. Now the other part of this is one of how on earth do you find A and B? Well, what you got to do is you have to set up an equation where, so that'll get you C. Let's do that. Minus 20, and then this one goes away, and we've got plus equals C times 21 quantity squared. Oh, minus 20 plus 1 is minus 19, Ted. All right, so this is C. C is equal to minus 20 plus 1 is minus 19 quantity squared. So that gets you C is, I knew it's going to get bad. 100 times minus 20 divided by minus 19 equals 105.26. Okay, so C equals 105.26. These are nasty numbers. Huh? I didn't square the 19? Okay, I got to square the, okay, yeah, sorry about that. Okay. So it's 100 times minus 20 divided by, this is minus 19 quantity squared. Equals, I got a mistake in it here, 100 times minus 20 divided by, parenthesis, minus 100 times 20, 2,000. So it's 2,000. One, 2,000 divided by 361 is equal to 5.54. So that's equal to C, and that's a minus 5.54. So now we found C. Now we don't know A and we don't know B. But we do know that there's a balancing act going on, and this is how you do this. You look at the S squared terms, you look at the S1 terms, you look at the S0 terms, and there has to be a balancing act. So on the left-hand side, for the A, there is 0 is equal to A times S squared plus B times S squared plus 5.54. There's an S squared term here, there's an S squared term here, and there's an S squared term here, and it's 1. But S times this, okay, so that's that. Now, to the S1 term, there's 100 on the left, is equal to how many A? It's S times 1 times S times 20, so it's 21S. So it's A 21A plus 21B is equal to, or plus, excuse me, these are probably going to be equal, plus C, or plus 5, okay, plus 5.54. And then there is an S0 term. There is no S0s, there's no term, just constants on the left. On the right, there is a 21, A times 21, plus B times 21. And there is a C, which should be, oh, that's S squared plus 2S plus 1. And this is times 2. This would be times 2. So there's there's 2 here, 21 there and 21 there. There's this 5.54 times 2, A times B plus B times B plus 5.54. There's one there's one constant over here, and C is 5.54. Okay, so now you got that. Now, what are A and B? Well, to me, they look like they're exactly the same, and they're exactly half of this. So each one of them is minus half of that. And I can just look at that and say that looks like that's going to work across the board because they're exactly equal. All right? Or they may be 0. There's no term that is A and B is equal to plus 54, and times 21 is equal to 54. So they both are actually 0. A and B equals 0. But that's what you got to do. In that case, that's a weird case, but that's what he did. That's this is a sneaky problem. All right? But you have to do this balancing act. How many s to the squared term, how many s to the 1 term, how many s to the 0 term, and that's the only one that will satisfy is, if you say A plus B is equal to, A plus B is equal to minus 5.54, you say 21A plus 21B is equal to minus 5.54, there is no number that's like that, so they have to be 0. Any questions about that? Weird one. A times s squared plus B times s squared. All right. That's just a totally weird question. Should be 20. This is should be 20, not 21. 21, 21, 20, 20, 5.54. Okay. When you get something like this, you know that they have to be 0. Okay, that's enough on that one. Not to worry about that kind of thing. Not to make that a big deal. Okay, 25. We're going to 25. All right, now this one is different. Okay, this one is a different one. 25. What's the deal here? 2000 s cubed over what? S plus 5 times s squared plus 4s plus 8. What's the deal here? All right. Let's just do 25a. I did 25b. Let's just do 25a. Okay, this one is the first one. Okay, forget about this. All right, 25a is 300. 300 times s plus 50 over s squared times s squared plus 40s plus 300. This is nasty, but this is the kind of stuff you're going to get because what I just said about the other stuff that you're going to get. Okay, so what are the splits here? This gets all really into the bad stuff. Okay, so why did I skip number 24? I skipped number 24 because it got really bad. Okay, but let's do this one. Okay, so what is the splits? It's a over s plus b over s squared. Now, why is that? Well, this contradicts the rule where that the numerator has to be 1 less than the denominator. but if you have a squared term, it's a number, it's a constant over the physical number plus a constant over the square of number. If you had an s cubed, there would be a plus c over s cubed. So this is the rule for splitting up like squares. All right, this is how you do this. Now, here you have a choice. You can say plus cs plus d over s squared plus 40s plus 300. Or you can say a over s plus b over s squared plus, this is called a complex conjugate. And it's the first one is called k and the second one is called k star. So you don't put the little star beside the first one, you put the star beside the second one. But you put the star by the, you do put the star by the second one, okay? Now you play the game here of s is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. This is called quadratic equation. Yes, sir?
And also factor it out.
You can factor this out if you want to. This is a mess. This is a mess. Why is it a mess? Because it's going to be a minus number in here. Because c is so big. He didn't do us any favors by making these big numbers. He really made it hard. Most of the time they put little numbers in there and it's easy to do, but this one's not. Okay, so what is minus, okay, s is equal to what? Minus 40 plus or minus square root of b squared, which is 40 squared, minus 4 times 1 times 300, all over 2 times a, or 2. S is equal to minus 20 plus or minus what? 4 times 300. 1200. So it's 40 squared. Let's just write it in here. Okay, maybe it is fact. Maybe you can get this one. Okay, you might be able to. It probably is. You got it. 25a, yeah. Yes, this one you can. S plus 10 and S plus 30. So you got that one. Okay, very good. Okay, so it's a over s plus b over s squared plus c over s plus 10 plus d over s plus 30, right? And that's it. You got to find these four variables. So let's just start from scratch. I assumed that it was going to be a negative number under there, but it's not. Okay, so here let's do it again. 25a. All right, it's 300 s times s plus 50, bless you, over s squared times s squared plus 40s plus 300. Okay, so this is equal to a over s plus b over s squared plus c over s plus 10 plus d over s plus 30. All right, now you write this out. 300 s times s plus 50 is equal to a times s times s plus 10 s plus 30 plus b times s plus 10 times s plus 30 plus c times s squared times s plus 30 plus d times s squared times S plus 10. So now we can find let S equal 0, what? Minus 10 and minus 30, and that will give you 3 of the 4 variables. The 4th variable, you have to do what I did just a minute ago to find the last one. This is not easy. Okay, so you get the B variable if you let S equal 0. You get the C variable if you let S equal what? Minus, if you let S equal minus 10, you get the C variable. You get the D variable, you get, excuse me, if you get, yeah, if you let S equal minus 10, you get the C variable. If you let the, you get the D variable if you let S equal minus 30. Okay, so you get B, C, and D by doing this. The only one left is A. You do the balancing act to get A. You do the balancing of the S's on the left equal the S's on the right, and you get A that way. All right? So again, I'm gonna let you crank through this, find B, C, and D using these 3, and then the A, if you say the S squared term, how many S squareds on the left? 300 on the left. How many S squared terms? There is a an A times S times 10 times 30, mess. You can get it. These are messy. Typically not going to happen. These are not going to be how you find most of them. But this is this question, and this is a messy one. I'll just be blunt. This is not one that I would give you in a test. But the process is still valid. You get the S squared or the S cubed term, and then you have to have so many on the left, so many on the right, and your A term is the one that falls out, and that's how you do this one. Okay. And now we're going to say enough for today. We're down to 25B, and we'll just start on 26 on Wednesday. These are not easy, but they're doable. And I don't know how many of them we can stand, but we'll do another day of chapter 9, and then we'll do a couple of days of chapter 10 and practice like all crazy until we get these down, until you can get these down. And then eventually we'll have another test. But this is what this is about. Does anybody have any questions? Because this is, again, not easy. Big numbers. Try to not have the difference between this course and the other course is the other course does not have such nasty numbers. This has got some nasty ones. Any questions? I'm going to stop. Take care.